Hello, my dear students. Once again, welcome back to your online class. So, hope every one of you are well known with the formulas of the integration and differentiation, as I have said you to memorize all the formulas of the integration, differentiation, and as well as that of trigonometry. So, today in this video, we'll be starting a new topic, that is the integration by parts. So what does this mean is, suppose if we have two functions which are both the functions of x, like I have two functions f of x and g of x. Okay, so getting the integral of the product of the two functions is known as the integration by parts. So in this, what we do, so we have the two functions, so we take one of the function as the first and the other as the second. So the integration of two functions will be equal to, it will be equal to the first function f of x into the integration of second function, that is g of x dx, minus the integration of the derivative of first function, that is dy dx of f of x into integration of second function, that is g of x dx. Okay, so this is how the integration by parts is done. So you must be very familiar with it. So it is the integration of first function into the second function will be equals to the first function into the integration of second minus integration of derivative of first function into the integration of second. So now here the problem arises when we have the two functions, one like one the algebraic, the other the logarithmic, or one may be the trigonometric, the other may be the exponential. So the integration will become more difficult, or it starts getting more complicated if you don't know the order of taking the first function and the second function. So you cannot take any one of the function as the first and the other as the second. So you must follow the rule of Lier. Okay, so it is written as Liate, Lier. Okay, but it always doesn't mean that this is the rule. Okay, the compulsory rule. In some of the integration or integrals, while integrating some of the function, the rule of the Lier does not work. Okay, so what does the Lier stand for? The first function, Lier, L stands for the logarithmic function, I stands for the inverse trigonometric function, the A stands for the algebraic, and the T stands for the trigonometric, and E stands for the exponential. So if we have two functions, one belonging to the logarithmic and other belonging to the inverse, so in that we'll take the log as the first function and the inverse as the second. Similarly, if we have the algebraic and the exponential, in that the algebraic will be the first function and the exponential will be the second function. So that is how we make the choice of the first function and the second function while we have the products of the two integrations or the two functions. So now we'll be solving some of the questions related to the integration by parts. So here I have taken three different types of questions. The first relating to the algebraic and the trigonometric. Here I have the algebraic and the exponential, and in the third I have the algebraic and the logarithmic. So we'll try to solve each of these one by one. So coming to the first problem, here I see we have the two functions. The first one x is belongs to the algebra, and the second it belongs to the trigonometry. So when we go for the rule of Liate, Liate, we see that the algebra comes before the trigonometry. So in this case, I'll be taking x as the first function and cos x as the second function. So now, following the rule of integration by parts, I can write this one as, so the integration of first function into second function is written as, so it will be equal to the first function into the integration of second, that is cos of x dx, minus the integration of the derivative of first function, that is dy dx of x, into integration of second, that is cos of x dx, and then finally the dx. So simply applying the formula, I have the x into integration of cos x is written as sine of x, minus, now integration of derivative of x is 1 into the integration of cos x is sine x dx. And finally, I can write this one as x into sine of x minus, now the integration of sine x again is cos of x plus c. So where c is the constant of integration. So this is how we solve the problems related to the algebraic and the trigonometric function. So now coming to question number 2, here we have the two functions, one belonging to the algebra and other belonging to the exponential. So again the algebra being the first function and the exponent being the second. So this is the first and this one is the second. So this will be equals to the first function into integration of e to the power 3x dx minus integration of the derivative of first function, that is d by dx of x square into integration of second, integration of e to the power 3x dx again dx. Okay, so this first dx is for this integral and this dx is for the first integral. So now again putting the formula, so I'll get x square. Now integration of e to the power x is, it is e to the power x, that is 3x divided by 3 minus, we have integration of derivative of x square, we have 2x and into integration of e to the power 3x. Again, here I can put the integration of e to the power 3x simply will be equals to e to the power 3x divided by 3 dx. Okay, so now it can be written as 1 by 3 x square e to the power 3x minus, now the constant comes outside the integral, that is 2 by 3 integration of x e to the power 3x dx. Now again here, what can I do? So again here I have the two functions. Okay, so x and e to the power 3x. Again here too, you will put the rules of the integration by parts and then we'll obtain the solution. Okay, so that is how we do the integration of the logarithmic, sorry, the algebraic and the exponential function. And remember that while solving the integration in such kind of question, you may have to apply the rule of the integration by part, not just once. You may have to apply it twice or thrice also. Now coming to the last one, where we have the function of the algebra and the logarithm. So here I see the logarithm comes at the top. So here I'll take the log as the first function and the algebra as the second function. So the logarithm being the first and this being the second. So this will be equals to the first function, that is the log of x into the integration of second, that is x minus integration of derivative of first function, that is d by dx of log of x into integration of second, that is integration of x dx. Okay, so whole bracket again dx1. So this will simply be equals to log of x. Now what is the integration of x? It is into, it is x will simply be equal to x square divided by 2 minus integration of derivative of log x is, it is 1 by x into integration of x, it is again x square divided by 2 dx. So x square and x get cancelled. Okay, so there now again I get log of x into x square divided by 2 minus the integration. So again, the constant sign comes outside 1 by 2 integration of x. Again, I can write x square divided by 2 plus c. So finally, we obtain this will be equal to x square divided by 2 log of x minus 1 by 4 x square plus c, where c is the constant of integration. So following the law of integration or the integration by parts, you may be able to solve the problems in which we have the integral of product of the two functions. So you may go through the solved example in your book and try to solve the remaining questions of your book. Thank you.